Dum, ba, ba, bum. I love you, baby, and if it's quite alright, I need you, baby. To all my lonely nights, I love you, baby. Trust in me when I say. Hey, there it is. Waiting for the signal there, brother. Looks like it's up. Man, had some technical difficulties today. Not sure what's up with that, but anyway, welcome back to the Swift and SwiftUI Learn Along, where you guys learn along with me, fly on the wall learning. So I don't interact with you, you don't interact with me, you just watch me learn, and hopefully you also learn. But really and truly, I mean, it doesn't sound like it's not a great pitch, but that is the premise. So learning this for the first time. For the uninitiated, we're going through this. We've already gone through an 800-page Swift book on the general purpose programming language itself. That's all on the stream. So if you're watching this, you can go back and watch that if you like. And just yesterday was the first day we started this new course specifically targeting SwiftUI called the SwiftUI Compendium. So we're stepping through that. There's a lot of reading yesterday, and that's fine, good information, but a lot of reading, not a lot of code yet, but we'll see what happens. So we're going to work through this, get a better feel for SwiftUI. After that, we're going to move into, Jared's looking at me like, you say, I know, dude, but we are. I mean, what do you want me to do? Anyway, we're going to do some, I know you made me lose my train of thought, buddy, some schema design for the local storage of my application. So all of this whole stream is part of me starting the company's already started, so it already exists. Now I'm learning the skill, Swift and SwiftUI, that I want to use to build the product. And so eventually we'll get to a point where we're also designing the SQLite rather, schema for the onboard storage, the local storage. So it's going to be an iOS app and an iPad app. I guess macOS too, just by virtue of now on Apple Silicon, they can run in both places. So we'll do that. We'll do some API design. I've decided I do want to use GraphQL, so we're going to try that. So just call it GraphQL. So we're going to do a schema design and a GraphQL schema. So if you've never seen how to stand up a GraphQL API, that might be cool to see too. So that's what we're going to use. I've done it once, and it was I was doing only one side of it. I wasn't writing the resolvers, so I want to do that part of it. But yeah, overall, it was enjoyable. So I think I want to use that. So we're going to use that, and then after that, we'll go back into more deep reading with the Big Nerd Ranch guide on iOS programming and other Apple APIs specifically. So we've done Swift, the general purpose programming language. Now we're doing the SwiftUI Compendium. We'll do a little bit of design after that, and then we'll move back into the books for Apple's APIs effectively. And so by that point, we'll have a pretty damn good look at what it means, what it's like to be a developer in this space. So that's the general theme of this. That's the target of this. And that's going to take a while, but once we're done there, I'm thinking maybe either Odin or C, one of the two, because I think that'll be a really good complement to, because both C and C++, not necessarily Odin, but it's so close to C, I'm okay with it. But Xcode supports those as well, and there's really no getting away from Xcode at this point. Maybe we'll see, but it's not been that bad. It's had some annoying quirks, but yeah, that's what I'm thinking long term for the stream. And then of course we are just going to build the app too. So you're going to see the actual process, watch me struggle and all that fun stuff. But if that sounds good to you, then follow along. If not, get the hell out. All right. So let's let's take a look at where we were yesterday, which is exactly what you see on the screen. And actually, yeah, we didn't get far into it. We're only on the second section, but so far it's been exactly as it was marketed, which is a good thing, meaning like this is just some random guy's course, that I bought online. But supposedly he has 10 years experience writing applications, and now this guide is not only here to teach us SwiftUI, but also a very important skill, which that skill is sifting through the actual documentation, meaning the Apple documentation, to find answers and how to arrive at solutions. Which, I mean, so far that's been true, and he is showing us how to do that. And so that is, to me, a very important skill, because coming from 10 years writing SQL and a couple years writing Golang, more in a DevOps environment, but still, mostly server backend programs, not a lot of GUIs. I've done some web dev stuff, just personal projects, but aside from that, that's the extent of my experience. But even with those technologies, any technology worth its salt, really. I mean, well, I shouldn't say that, not worth its salt, but any technology that is capable of creating other technologies like programming languages, it's going to be that way. I mean, you're going to have to understand how to look through the documentation, because you can't always rely on the given technology to have enough content out there to support exactly what it is that you're trying to do. Now, if you're using something like, some JavaScript framework, God bless you, but yeah, I mean, you probably can find more content, right? But that's not what we're doing. Now, is it? No, it's not, brother. But no, that's the general idea. So I find this very valuable, and so so far so good. So far, I give it a 8 out of 10. I'll give it 8 out of 10. Now, the book, the Big Nerd Ranch Guide, we just finished reading, the one on Swift, the 7th edition. My girl was asking me that yesterday. What would I rate it? I would give it a 9. It was a damn good book. I know I always say that, but I mean, I don't make no money off it, brother, so I ain't got no reason to tell you that other than it's what I believe. But yeah, if you're looking for really anything in the programming space and you're a booky kind of person, you like books, digital or physical, check out the Big Nerd Ranch Guides. They got a lot of them. All right, so with all that out of the way, let's just get right back to it, brother. So on the top half of the screen, what you see is Apple's documentation. On the bottom, oh, hold on. My love, can you please give me... Duh. Hold on one second. Taking care of duties. All my duties. Gotta send. Gotta pay for all the booties. I don't know what I'm saying sometimes. All right. Actually, I always know what I'm saying. That's the scary part, isn't it? That's really the scary part. Okay, so there we go. There you go, babe. Like that, babe. Okay. All right, now, so the top half, what you're looking at is damn, neck stiff as hell, brother. Got bobblehead going. Apple documentation, right? So I'm just splitting it like this just so we can, really more for the Insta folks, but you got to pander a little bit. All right, so but that's what we're looking at. So the course is on the bottom. Docs on top. Doesn't really matter. I'm reading it to you anyway. Just kick back, brother. All right, but this is where we left off. So effectively, let's see. Let me look for key points from yesterday. There were some... but then I got to go back. Maybe we won't. Just go watch the stream. How about that? No, I mean, really, we just got into the foundational aspects of SwiftUI and how everything is more or less just getting stacked upon. Let me attempt. I'm gonna attempt my little drawing here, just to conceptualize it a bit. But everything is very HTML-like, right? So we learned that views are effectively HTML elements, so that's how you can think of them. Not views in the web dev sense of like a window or a canvas size thing. It's just everything's a view. So if you can imagine, the browser that you're looking at is an iOS screen, your iPhone screen, your iPad screen. All of these, like text, just regular text, with a capital T, they would consider a view. This toolbar element here, they would consider a view. This sidebar nav with these links would be a view. So it's not just like in totality at least what I thought of as a view previously. They're calling views, I guess, what I would previously refer to as like components or elements. I don't know, but it doesn't matter. Right now, we're speaking Apple's language, and so that's what they call views. So almost every individual entity on the interface is a view to them. So it's all just composition that's been the popular paradigm, and it works well. So I mean, I like that it is, but that's the essence of it. And then in terms of how it works a lot like CSS. So if you've ever worked with cascading style sheets in the web dev space, this is very similar to that. So if you have, say, a parent view, each of these are views. Every single square. Views. And so let's say the red one is the parent. And then you got something inside of it. And then another thing inside of it. Right? And so at each point, well, hold on, let me label so the red dilly, this would be the content view. And this is literally a type in SwiftUI. So this is a thing you would actually see in the code, and you'll see it here in a second. But this would be the content view. So this encompasses the actual viewing window, the thing that we look at. But then beneath it, you have all of these other objects that they call views. And each of these can apply modifiers. So at each step, let me make that a little skinnier. And there. Now the skinnier is better and relaxed, but okay, so here you can have modifiers. So say on this blue square, right? You can modify it and add, say, dot font 12. That's not what it looks like, but it is a dot font. You would just put that. You know what? Why don't I just do it? Why don't I just not be lazy? There you go. Font 2. Okay. So that would apply to if we don't do anything else. And we're saying that this modifier, as you can see, it's very close to that blue line, right? So let's say it applies to the blue frame, whatever that view is. And then inherently, it would also apply to anything beneath it. So from blue line down, anything that we apply to the blue will also apply to the black. And if we also were to add, say, yet another view beneath it, it would also apply there, meaning the font. So any text would get font 2, font size 2. Who is this? What? Yeah, GoDaddy really needs to leave me alone. I should just, you know what? Let me just reply. Stop. In all caps, stop. Fucking bothering me. Okay, there we go. All right. I realize I do that a lot. I know how to make things stop, but I'd rather just bitch and moan, but I don't make it stop, and then it does it again, then I bitch and moan again. It's a terrible cycle, but now it's stopped. All right, but anyway. So that's what we're working with here, right? Oh my God. Okay, great. All right. So that's what we're working with, right? So this font applied to blue would apply to blue, black, and green unless you explicitly state. So they do call them, or they use the parent-child terminology. So red would be the parent of all of these. Blue would be the parent of black and green, right? But you do have the option of negating this font 2 that's coming from the parent if you were to apply it to a child. So if you wanted to have, say, font 2 on blue, black, but not on green, then you can then apply another modifier of the same namesake. And so the compiler will see when you do that, and if there's a modifier directly on the child and also one coming from the parent, it will take the child's modifier. That's basically what we learned yesterday. So it's very similar to the hierarchies that are present in web dev, if you've ever done that. If not, I think it's still pretty straightforward. So everything beneath the parent inherits the properties of the parent unless told otherwise. Pretty straightforward. So far so good. And I think we're all caught up now. And so I guess back to reading. Hopefully we get into some code today, but I can't promise you that because I've never taken this course, so we'll see. All right, so now 2.3, configuring text. I think we were further along. We were somewhere down in the we'd gone over the type stuff. Oh yeah, we did the resizing. Why don't we'll just restart here as though we didn't, because I think this images are obviously a big deal, so we'll just go through this again. All right. Resizing and tiling images to fit them in an app's interface. For images, refer to the images section. Dive into the documentation page for the image type and fitting images into available space article to gain more information on configuring images for different purposes. If you create apps that retrieve resources from the internet, which ours will, we'll use, let me shout out another product that I really, really like. I think it's just so damn cool. And I love it. I think I ended up, let me not tell on myself. They made a mistake and they ended up giving me like a pro license for like half a year for free. I think they finally caught me though. Let me see. But yeah, so it's CodePen. And the wonderful thing about, oh, they never, don't worry, I'll pay for it. I'm not encouraging this, but yeah, I don't know. I'm really curious to see how long this would go on. Because I paid $144 for a year in 2022. Obviously, it's now 2 years later, but I'm still on the pro plan. Whatever, it doesn't matter. But look at this. Check this out. So you can have, like, this is one that took way longer than it should have, but it's really neat. So you can have, I mean, it's a code editor. But it's so nice because you can just pop in and just make a quick visual. See, it splits out your HTML, the CSS. So these would effectively be the Swift modifiers. And as you can see, they look, pretty similar, except Swift is using the dot notation. But a lot of the syntax and the actual names of the properties, content, width, height, background, all that stuff is the same. So that's another big upside to me about SwiftUI is it's very close to web technologies. So you can kind of bounce between the two, since the web is, if you're going to write apps, it's inescapable, regardless of what platform or what language that you use. But yeah, this is a really cool little tool. And not only can you, make your own little snippets like this, share them, publish them. You can even have full-blown apps if it's just like if you don't need a backend. You can host apps on CodePen, and you can also check out community stuff. And if you like someone's design, just yank that shit. It's encouraged, it's not stealing, but I just think it's funny to refer to it that way. But it really is, it's encouraged. So that's one of the nice things about this platform is not only can you store work and use it as a CDN, which I am doing, so you can have assets with the pro version. You can also, let me just show you this real quick. Because some of the things that people make, I'm proud of my little ugly ass candle, which is pretty sick. But some of the stuff, let me just show you a couple of, let's just go to trending. Like, look at that, look at what, even just this. That's incredible. Like these text characters made that. Huh? Well, maybe I'm nerding out a little bit, but It's incredible. And you can learn so much because you can see exactly what, the code is doing. And if you change it, yeah, like let's get rid of that. It probably won't let me, yeah, there you go. I don't know. I'm harping on it a bit, I know, but great tool, especially if everything you do is in the front end. Leave site. Yeah, go ahead. All right, so, but anyway, yeah, so we will need to look at this closely, the async image. Oh, this is out of scope of this course. You can learn more about internet connected apps in my other course. Well, we're not going to do that because we have the other book coming, so we'll stick to this. All right, so from images, refer to the, and you want me to read this article, which I'm pretty sure this is, yeah, this is that article. We were already there. So let's just start back up at the top. All right, fitting images into available space. Adjust the size and shape of images in your app's user interface by applying view modifiers. All right, so how do we scale a large image to fit its container using resizing? Consider the image landscape 4. It's JPEG. A photograph with the dimensions 4032 by 3024 showing a water wheel, the surrounding building, and the sky above. So here's our starting point. That's pretty neat. The following example loads the image directly into an image view and then places it in a 300 by 400 point frame with a blue border. Okay, so here's the code. So image would be yet another type of view according to SwiftUI, just to stick with the terminology there. So image, and then the name of the file in a string here inside as the single argument. And all of these dot notated terms here are what they call modifiers, which are just methods, which methods are just functions that are nested and assigned to a particular type, and that type would be an image. Okay, cool. All right, so modifiers, so dot frame, and everything, of course, per the example, the beautiful example I laid out at the beginning, the modifiers are applied in sequential order. So it does matter what order that you have things listed in terms of modifiers. Right, yeah. I had to make sure that's correct in my mind, but that, yeah, that's correct. So, and they'll show us that here in a second. I remember this example now. But yeah, so here's a modifier. Each modifier may or may not have arguments that you can give it. In this case, this one obviously does. It has 3. So the width, just separated with the colon, is 300. And this is in pixels, right? These quantities. And then the alignment. And all of this stuff we learned, through Xcode. So if we look at, you can see a lot of, well, let me make it a little bit smaller. A lot of this stuff you can see by just holding control and just clicking the, in this case, I clicked view. You can click anything relative, any SwiftUI term you could click on, and it will take you to the implementation. So what we're looking at isn't the source code, but it's the public interface that SwiftUI exposes to us as developers. So that's what we're looking at. But what's really nice is it's pretty well laid out, and as you can see, all these comments, there's a ton of information and examples, which is awesome. So if you're ever lost, I don't know, so far I found this, like the actual interface, as in the code, to be a little bit more helpful than the documentation. This just seems more closer to the, I don't know, the information is more relevant, I think. But either way, there are multiple ways to find information about this. So you could also do, if you open up that right sidebar, if you go to the little question mark right there, you can also get to the documentation if it's available in that little sidebar, which is also nice. All right, so that being said, that's where you can find all of these. Like if you're wondering where the hell do you find like a frame, border, that's where you just go beneath the type somewhere. There will be a listing of all the modifiers and whatnot, and along with it, all of its potential parameters and stuff like that. Okay, as seen in the following screenshot, the image data loads at full size into the view, so only the clouds from the upper left of the original image are visible. Because the image renders at full size, the blue frame is smaller than the original image. The image displays beyond the area bounded by frame. Okay, so they're saying with this type of code, so the image, and then we want this frame applied directly to the raw image, and then we want a blue colored border applied to the frame. Oh, and another thing before we move on that we need to understand, or keep in mind rather, is that each time that you use any of these views in SwiftUI, it's always returning a view. So the return is implicit. So you can just kind of think of it as like this is a view, which is this, just the picture. And then you apply this modifier to it. So it takes what it was, applies this, and then returns a new thing. So here's a thing, and then after this, it's a new thing with that applied, and then so on and so forth. So then border would take whatever this spits out and apply it to that, and then return the result. So whatever your last expression is when you're using these views, just remember there's an implicit return. We don't have to, because we saw when we were working through Swift, there were times when you have to actually, do return, and then, something dot whatever value you want to bring back. But this is doing that implicitly. We're not having to write return view. Okay, so this is the result of this code to this picture. Clearly a little fucked up, right? So to fix this, you need to apply two modifiers to the image. Resizable tells the image view to adjust the image representation to match the size of the view. Okay, makes sense. By default, this modifier scales the image by reducing the size of larger images. Size larger and enlarges images smaller than the view. By itself, this modifier scales each axes of the image independently. Aspect ratio corrects the behavior where the image scaling is different for each axis. This preserves the image's original aspect ratio. Yeah, so without this, that means if you've ever jacked around with photo editing software and you can pull the individual edges and then it contorts the image, that's what resizable would do without aspect ratio. But when adding aspect ratio, then we can also tell it, okay, resize it to fit, but maintain the aspect ratio of the original picture. So it's not skewed or contorted. All right, corrects the behavior where the image scaling is different for each axis. This preserves the image's original aspect ratio using one of the two strategies defined by the content mode enum. Yeah, so we have a choice to either fit or fill. Okay, so now this code, if we wanted to apply that, so same image, same starting point, but first we call resizable, then aspect ratio, and we choose fit. So we want to fit the entire image into the frame, which is defined here, and then we want a border around the frame. And we get this, a chopped off picture. Keep image data inside the view's bounds using clipping. If you use content mode.fill, which is, that's the result here of fill. Wait, right? No, sorry. Fit. This is what fit gave us with this code, not fill. All right. If you use content mode.fill when scaling an image, a portion of an image may extend beyond the view's bounds unless the view matches the image's aspect ratio exactly. The following example illustrates this problem. Okay. So we call image view, still resizable, aspect ratio. Now we're using the fill strategy instead. What the hell? Then we apply the frame and then the border, and this is the result. So we have the bounds and the border, but we don't necessarily want this because it's outside the border. To prevent this problem, add the clipped modifier. This modifier simply cuts off excess image rendering at the bounding frame of the view, meaning it would just cut it off at whatever we define as the frame, in this case 300 by 400 here. Simply cuts off. Yeah. Optionally, you can add an anti-aliasing behavior to apply smoothing to the edges of the clipping rectangle. Okay, this parameter defaults to false. The following example shows the effect of adding clipping to the previous fill mode example. Okay, so everything is the same. Strategy fill, the border, but we add clipped, and then that extra content that was here falls off. Cool. Okay. Yeah, that's the problem. I mean, sometimes there's just not a... It just, you got to understand aspect ratios, so it's not always going to work out. Kind of like a good example is the Instagram stream. Like I can make it look decent for portrait mode, but really and truly the stream is meant for landscape. So portrait has to get, you have to make some sacrifices basically. There's no way to make it look as good because it simply, they're different aspect ratios. You can't optimize for both. Use interpolation flags to adjust rendered image quality. Rendering an image at anything other than its original size requires interpolation. At anything other than its original size. Okay. Yeah, I wonder how that, okay, I mean, obviously we'll find out, but the only other interpolation we've encountered so far is string interpolation, so it seems a bit out of place here. But anyway, interpolation, using the existing image data to approximate a representation at a different size. So some kind of algorithm to arrive at the scaling, or correct scaling, if we need to change the original aspect ratio at all. Okay. Different approaches to performing interpolation have different trade-offs between computational complexity and visual quality of the rendered image. They have different trade-offs between computational complexity, which I suppose from an app developer's perspective, computational complexity equates to more performance overhead. So maybe, or more or less it's saying you'll have to strike a balance between, you know, the images that you're sharing and the quality at which you want to render them to your user versus what's the user experience going to be like by doing that. You know, if you're trying to load a bunch of 4K images every time on a refresh or, you know, something along those lines. So that's what I'm taking that to mean. You can, because, I mean, I say that because we're not actually, I mean, I guess you could, but we're not actually writing like the compression algorithms or the scaling out, you know, we're not doing any of that. That's just all libraries provided for us, tools provided for us, low-level tools. Not saying it takes no skill at all, but we're not actually, you know, writing those algorithms. Anyway, you can use the interpolation modifier to provide a hint for SwiftUI rendering behavior. Okay, it's easier to see the effect of interpolation when scaling a smaller image onto a larger space because the rendered image requires more image data than is available. I see. Consider the following example, which renders a 34 by 34 image named .green into the same 300 by 400 container frame as before. Okay, so image.green, resizable, interpolation ahead of aspect ratio. Okay. Well, hold on. I still don't get what it's... Let's go look at this real quick. What is it doing? It's an instance method. Okay. Interpolation specifies the current level of quality for rendering an image that requires interpolation. Func, interpolation, anonymous parameter, interpolation, internal parameter name, image.interpolation. Okay. So that, okay, so that's just saying it needs to conform, or that is the type. Yeah, okay. So whatever we pass to it has to be of type image interpolation, and it returns another image. interpolation, the quality level expressed as a value of the interpolation type that SwiftUI applies when interpolating an image. Yeah, its return is an image. Makes sense. Discussion, see the article we're already reading. Okay. Yep. Yeah, specifying rendering behavior. Oh, those are other things. Okay. Yeah, I mean, this is not, whoops. This is not a lot of information really, but I guess it makes sense because it's just a public interface. It's not the actual like implementation details. We can't see that with SwiftUI like we could see with Swift, but nonetheless, where were we? Yeah, easier to see the effects. Okay, we were reading this. Yeah, image, aspect ratio, frame, and then border. Passing the image interpolation.none value to interpolation produces a highly pixelated image when rendered. What's the... Oh, it didn't show us the before. Okay, so that's what we get. Okay, so this is a 34 by 34 image being stretched effectively to be a 3 by 400. And looks like dookie. All right, if you change the interpolation value to image interpolation medium, SwiftUI smooths out the pixel data to produce an image that isn't as pixelated. Okay. You can also specify interpolation behavior when scaling images down to ensure the highest quality image possible, fastest rendering time, or a behavior in between. Fill a space with a repeating image using tiling. When you have an image that's much smaller than the space you want to render it into, another option to fill the space is tiling, repeating the same image over and over again. To tile an image, pass the image resizing mode.tile parameter to the resizable. Okay. Image.green, resizable, resizing mode.tile. And then we apply the frame and the border. And that's what we get. That's neat looking. Tiling can be particularly useful when using an image that, when placed end to end with copies of itself, creates a larger pattern with no visual discontinuities. Okay. So when you find generic types, look for concrete examples. After reading the descriptive text in each guide, examine the various initializers and view modifiers available for each type. This step is essential whenever you aim to achieve specific results or work with a particular view. It offers a comprehensive overview of the framework's features. However, sometimes you might encounter a roadblock such as Swift generics. For instance, take a look at this initializer for the text type. Okay. Oh, okay, I can do that. Sweet. Open link in top. Ah, beautiful. Except it didn't work. Okay, there it goes. And this is why Edge is the best browser. Better than Chrome. Yes, you're missing out. Yes, it's a Microsoft product, but it's still Chromium under the hood. And you get features like this. It's annoying having to turn off all the fucking Bing shit, but once you do, it's totally fine. And it's great. And all your all the Chrome extensions work too, so yeah. Anyway, creates a text view that displays oh, one more thing. Vertical tabs, baby. Eat your heart out, Chrome. You ain't got that either. All right, creates a text view that displays the formatted representation of a non-string type supported by a corresponding format style. Creates a text view that displays the formatted representation of a non-string type supported by the corresponding. Okay, that was a mouthful. Okay, so init. So here's a, this angle brackets, the pokies indicates a generic. So we know immediately this is a generic. but this just means F can be anything. F can just be any concrete type like string, text, view. So everywhere you see F, you can just think of it as all of it's going to be the same type. So if we did image, this would be image, format image, where image, format style. See what I mean? So it's a construct for many different things, but just think of F as whatever intended type that you're going to use this construct for. So initialize, we're saying the input is, then we give it the format type. I guess, oh, the format input. Okay. So whatever we're going to feed it, and then whatever the format that we want the output to be. And then this is just a conditional where the type conforms to format style, input, equatable. And these are all, I assume, protocols. Except for this here. Oh, and we have to return a string in this case. I guess that makes sense because it would be encoded, and then you would decode and then render whatever the thing is. Okay. And then parameters for this initializer. Input the underlying value to display. So like what's the not gzip, the format you send up to S3, it's really common. I can't think of it. It'll come to me. Format, a format style of type F to convert the underlying value of type F dot format. Wait, a format style of type whatever to convert the underlying value of type. Oh, so it's converting type of F dot format input to a string representation. Format style. Oh, okay, yeah, okay. So yeah, so the output format, yeah. Discussion. Man, what is it called? There's some. Let me just search it real quick. This is the common encoding for images. Base 64. Yeah, there you go. Base 64. So yeah, so that makes more sense with an example. Wait, where was I? Here. Nope, not that one. Must have been. Damn, where was it? Where was the. Oh, here it is, yeah. Yeah, so that's saying the input would be base 64. F.format would be the format that you want to apply to the base 64 encoding and then output the new string, for example. All right, use this initializer to create a text view backed by a non-string value. A text view backed by a non-string value. Using a, hold on, I gotta. Let's, what is meant by the passage when it states text view backed by a non-string value? It's interesting. I also often find the way that people describe things. Of course, this is Apple's way of doing it. Not that it's bad or anything, but if you break down, like, there's a lot more information in the words surrounding the keywords than can be derived from the keywords themselves, because a lot of times it's just like a thing. So you have to understand the concepts and how they interact. That's why I always take breaks to try to really dig into the word choice. I just find really with anything, I learn more from that than just reading, effectively reading like an encyclopedia. You know what I mean? The passage is talking about a feature in SwiftUI framework where it can create a text view, a user interface element that displays text, right? That is backed by a non-string value. Okay, here's what it means: backed by a non-string value. This means that the value which the text view is displaying is not originally a string. Okay, thank you. That's a perfect, yeah. Okay, so backed by a non-string value. The original value that we pass to it, to the text view, it's not originally a string. So we give it an image or something like that. Okay, and then it gets represented as text. It could be any other data type, like an int, float, date. Using a format style to convert the type to a string representation. Since the text view displays text, non-string values need to be converted into a string format. This conversion is done using a format style. For example, a date value can be formatted to a string to display month, month, day, day, year, 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 year format. Okay. Yeah, that's it. Okay. You know what? That's, oops. I like that so much. I'm gonna put it on the board once it loads. Pretty sure I had a SwiftUI, yeah. So first one, and representing non-text values. That's text views in SwiftUI. Okay. Any changes to the value update? Yeah, that's fine. Okay. Now where were we? Use this initializer to create a text view backed by a non-string value using a format style to convert the type. So this would be a good example for base 64, because that's, you could do that and display it as a string. To convert the type to a string representation. Any changes to the value, update the string displayed by the text view. In the following example, 3 text views present a date with different combinations of date and time fields by using different date.format style options. Yeah, let me save that too. That's a much better example than my base 64, because that's really more of a, I mean, yeah, you can represent it on screen, but that's really not what that, that's more like for storage compression, then you can store them in S3, and then when you call it from S3 with some identifier, like the file name that you could store in Dynamo or something, then you can decode it and get your image back. So that, yeah, this is a much better example of than what I said. So let's save this here. Payal. Java, who the don't insult me, brother. Yeah. Java. What is this, 1888? All right, so then let's go back. 84. Oh, that's the end of it. Okay, so now back to the course. Take a look at this initializer. Okay, we dug through that. When faced with symbols using Swift generics, hold on, I gotta suddenly. Nature calls to me. I must answer. Should not take long. BRB At what time is it? 1:40. 10-minute break. Go get some water. How about that? Or just sit there. P. Yeah, 1:57 CST. It'll probably be earlier than that, but you never know. All right, be right back. quite alright. I need you, baby. My lonely nights, I love you, baby. Hot dog. Okay. 1 minute early. 1 minute early. Ha. All right. Sorry about that. I apologize to you for. Don't even know you. All right. So, where were we, brother? Ah, yes. When faced with symbols using Swift generics like this one, checking if the documentation provides any sample code is beneficial. Generic code is often clearer in its applications than in its declaration form. That's a good point. Yeah, I never thought about that. Okay. Yeah, understanding documentation that includes generic types. Oh, this is a great section, yeah. Unfortunately, not all symbols have detailed discussions about their usage. I need a quick definition on symbols. I can kind of infer, but why infer when you can just get the answer? So please define term symbols in the Swift. Wow, it really is just programming. Symbols are identifiers used to represent specific elements within a program's code. Okay. Oh, okay, okay. So that's like a macro term for all of the primitives, variables, functions, classes, structures. Okay. Now that makes sense. All right. Unfortunately, not all symbols have detailed discussions about their usage. Hence, you need to grasp these types of declarations, at least superficially. The initializer above employs a generic F type, which could represent any Swift type. However, generics usually come with restrictions. Well, let me get that on screen because it'll be hard to. Damn it. If only there was a hotkey so I didn't have to use macOS's trash ass fucking drag. Okay, here. So that's what we're talking about. The initializer above employs a generic F type, hotkey. And so when you see a generic with this pokey syntax, just remember that everywhere else that you see F as well, I mean, it seems obvious, but maybe not. It's saying, or it's referring to the same thing. It's not a placeholder for many different things. Everywhere you see F would be a type. Okay. So, where was I? The initializer, which could represent any Swift type. However, generics usually come with restrictions, typically in the form of type constraints and where clauses. Yep. The first type constraint here is F format style. So this first argument ahead of the, because these are comma separated, so first constraint. This constraint specifies that the F generic type must conform to the format style protocol. Yep. And another thing is, because this would throw me a lot too, by convention, you might normally see certain values, like here it's F. It could be anything. It could be booty. It could be treasure trove. You know, it's just a placeholder. So by convention, you might see common things used for generics. Oftentimes, hopefully, they lend towards, you know, a better understanding, but ultimately they just represent a placeholder. So just remember that. Let's see. Well, in this case, okay, I misspoke. That's not true. I should be honest about this, or more accurate. Generally speaking, what I said is true, but in this case, there are constraints, and they're in the where clause here. Yeah, so in this case, format style, format input, so on and so forth. Clicking on that protocol leads to its documentation page, revealing its requirements. At the bottom, you find a list of types that conform to it. These conforming types are candidates to be used in the text initializer. Okay. Well, I think we already went there, so I'm not going to click on that. You'll encounter the format input and format output. Where is that? Oh, here. Format output. Associated types among the protocol requirements. Yes. As seen earlier, these are generics that can represent any type, but they come with constraints within the text initializer declaration. Within the text initializer declaration. Oh, I see. Okay. So they could be any type, but when using it via this initializer, they're saying these apply. And I mean, and that makes sense because the initializer is relative to the image type that we were looking at. There you can see two additional type constraints. These constraints stipulate that the format input associated type, so this guy, must conform to the equatable protocol, which is this syntax, that colon equatable. So that's the Swift protocol itself. And the equatable protocol, we covered that one. So that one was, you have to implement an equality operator, so the double equal sign, so this thing here, and a less than. And then the compiler will do the rest for you. And the format output associated type must be a string, which is what we're saying here. This implies that among the types listed at the bottom of the format style protocol documentation page, only the ones whose associated types satisfy these constraints can be used in the text initializer. Although this process might seem cumbersome, you typically aim to achieve a specific result when browsing documentation. In such cases, scan the list of conforming types and check if any align with your needs. And since generics are more straightforward to understand in their application, you can always attempt to type a symbol in the Xcode editor to see if it's accepted or generates an error. Yeah, the old tried and true trial and error. Works every time. Well, until it doesn't. But laying out basic interfaces with stacks and view builders. Yeah, let's move on. All right. Stacks serve as fundamental components in SwiftUI layouts. However, they should be considered a last resort choice for interface design rather than the initial one. That might sound controversial. It does. So we'll clarify what this means in practice in the next module. Okay, great. To begin, read the Building Layouts with Stacked Views article in the documentation's Layout Fundamentals section. All right, so let's peruse that one. All right, building layouts with stacked views. Compose complex layouts from primitive container views. Overview. Individually, HStack, VStack, and ZStack are simple views. HStack positions views in a horizontal line. Okay, so here's an HStack. Actually, I'm jacking this. Save. I like that. Oh, I lost my spot. Okay. HStack positions views in a horizontal line. So view, view, side by side, aligned. VStack positions them in a vertical line. Aquí. And then ZStack overlays views one on top of another. Yeah, this is pretty cool. And notice that this one, we learned this from a, well, I forget what I think it was actually in the Big Nerd Guide or whatever, but you see how you can see the view text through the green. So the ZStack will actually allow you to apply opacity and stuff like that. So, you know, cool little neat effects, or to simulate like a stack of papers, you know, with the light passing through it, that kind of a thing. But yeah, so that's a special property of Z-stack that I need to remember once we get building. When you initialize them with default parameters, stack views center align their content and insert a small amount of spacing between each contained view. Okay, so just by default, we get this little area. So a centering and then some kind of default spacing between. But when you combine and customize stacks with view modifiers, spacer and divider views, you can create highly flexible and complex layouts. Okay, plan your layout hierarchy. Think about a layout in terms of how you might create it using the various types of stack views as you start to translate your design into code. Break down complex designs into smaller, simpler pieces, and you can build. Break down complex designs into smaller, simpler pieces you can build with stack views. For example, you might build this profile view using 3 stack views. Okay, so on the left is the end result. On the right is that representation of the stacks being composed. I'm gonna save that too, yoink. All right, so we have a spacer, which is these square dealies, I guess. That's a spacer. The Z stack, which is this whole thing in totality, each of them. We have an image, so just straight up image on the in-between layer. A horizontal stack, which contains the 2 spacers, and then a virtual stack that contains these 2. I guess these gray lines are meant to indicate, rows of data or something along those lines. Okay, yeah, I mean that makes sense. So you have spacers, a vertical stack, a horizontal stack, an image behind that, and then all wrapped in a Z stack. Okay. Whoops, get back over here. A Z stack contains an image view that displays a profile picture with a semi-transparent H stack overlaid on top. Okay, the H stack contains a V stack with a pair of text views inside it, and a spacer view pushes the V stack to the leading side. Okay. To create this stack view, here's the code. So it's a struct profile view of type view, or conforming to the view protocol rather. Then we have the body, which is required, and then some view is the opaque type conforming to that protocol, which just means we can use this for any concrete type that conforms to the view protocol. Then we have the Z stack at the top level, so that's wrapping everything. Right? Yeah, that's wrapping everything. And then here's a parameter we can apply. So bottom, inside of that, we have the image view, the name of the picture, modifiers for the image itself. So we want to be able to resize it, and we want to maintain the aspect ratio with a strategy of fit. So we get the entire image. Then we have the horizontal stack. So this wraps all of this here. Wait. Here. Or no, sorry. All of this. Yeah. So the horizontal stack wraps the vertical stack, which was this part right here. Leading alignment. And then for each text, we have the actual string. And we're applying this headline font formatting to each of these strings. And then a spacer. I wonder what spacer. Oh no, they said it. Okay, that's what it is. Okay. Spacer with so if we see it with no values inside the parentheses, we're just using whatever the default is for that type implementation, which we could see if we were to do that command click inside of Xcode. And since this is the end of scope for the stack, right? Because this is one, yeah. So all of these modifiers would then be applied to everything inside the horizontal stack. So all this stuff, provided it even applies, and also provided there was not some property on the children that negated the spacer. I don't know if that applies to spacer, but you can negate. We just, at this point, we know that we can control whether or not a formatting, or rather a modifier, cascades all the way down to all children or to just some. So we know we can control that to some extent. And these are just modifiers. Okay. Position views with alignment and spacer views. Position views with alignment and spacer views. What is align any contained views inside a stack by using a combination of alignment property, spacer, and divider views. Okay. In the previous example layout, the V stack that contains the two text views uses the leading alignment. Leading, dot leading. So this is leading. Okay, so I guess that's their way of saying left justify is what I'm used to seeing it as, but that's what that looks like. So leading, left justify, center makes sense, and then trailing is right justify. Okay. I'm gonna save that too. I saved it twice, god damn it. The alignment property doesn't position the VStack inside its container. Instead, it positions the views inside the VStack. Right, so we also learned yesterday that the VStack and the horizontal stack and the ZStack don't actually have any view themselves. So there are some views that are only meant to contain other views. Otherwise, they have no rendered output. So earlier when I said there's always an implicit return, that's true, but some don't return anything unless it's holding some other view inside of it. So these are more like, you know, groupers, supervisors, ways to represent other views, but have no representation unique to themselves. The alignment property doesn't position VStack inside its container. Instead, it positions the views inside the VStack. The alignment property of a VStack only applies to the horizontal alignment of the contained controls using horizontal alignment. Let me see what it's... VStack. Maybe it's just saying that generally speaking. I thought it was talking about the example, but I don't see what it's talking about. The alignment property of a VStack only applies to the horizontal alignment of the contained controls using horizontal alignment. Similarly, the alignment properties for an HStack only control the vertical alignment using vertical alignment. Okay, I see what they mean. Finally, you can align views inside a ZStack along both axes with alignment. Use spacer views to align views along the primary axis of an HStack or VStack. Use spacers to align views along the primary axis of an HStack. So the x-axis, or a VStack, y-axis. Spacers expand to fill any available space and push content apart from other views or the edges of a stack. View, okay. So by default, the spacer is applying to all sides of a thing, and it's trying to I guess unless specified otherwise, it's going to apply it to each corner of the stack. So if we give it a value, then by default it's going to apply it to the top, to the bottom, left, and right, like it's doing here. So all around, and then the next view, so on and so forth. Oops. Okay, so view, spacer, view, spacer, view, spacer view. Okay, I don't. I mean, I guess I just, yeah, okay, maybe label them. Divider views also add space in between a stack's subviews. Divider views also add space in between a stack's subviews, but only insert enough space to draw a line across the stack's minor axes. Wait. Also add space in between a stack's subviews, but only insert enough space to draw a line across the stack's minor axes. They don't expand to fill available space. Oh, okay. So a spacer will fill empty space within the given container. So if there's two views and I use a certain spacer, it would just fill up to the point between the two views, depending on where I see what they mean now, depending on where I call it in the overall stack. Okay. Okay. Create adaptive layouts instead of explicit layouts. Wherever possible, define structure and hierarchy rather than explicitly positioning view frames. Instead of using explicit heights and widths for views, let them expand to fill available space. Adaptive layouts that you build adapt more easily to different device sizes and platforms. It is possible to create this article's example layout with 2 stack views rather than 3 by manipulating the text view frames explicitly. While the output might look the same, the code to implement it is more brittle and might not scale as well across devices of different size classes. Yeah, because you're hard coding some sort of positioning on the screen relative to a particular device. So if you use it on a different device, then your hard coding is not going to translate well. You may need to make adjustments to a layout that uses explicit adjustments by using view modifiers such as frame, width, height, alignment, or position XY. But only consider this when you can't achieve your desired layout in an adaptive, flexible way. For more information on making fine adjustments to view layout, see making fine adjustments to a view's position. So we won't click off as we were instructed, although it sounds enticing. Add depth in alternative ways. In some situations, it may make sense to add depth to your layout by using the overlay alignment and background alignment view modifiers instead of a Z-stack. Okay. The background view modifier places another view behind the view you're modifying, and overlay places a view on top of it. Choose between a stack-based approach and the view modifier approach based on how you want to determine the size of the final layout. How you want to determine the size of the final layout. Oh, so if we wanted code to determine, are they on iOS, are they on an iPad, are they landscape, or are they portrait mode? Okay, if your layout has one dominant view that defines the size of the layout, use the overlay or background alignment view modifier on that view. Wait, if your layout has one dominant view that defines the size of the layout, okay. Use the overlay or background alignment view modifier on that view. If you want the final view size to come from an aggregation of all the contained views, use a Z-stack. So I guess if your app let the user have some kind of visual control over how many elements or things are on the screen at once, kind of like kind of like board mix. Like, this is pretty flexible, right? I mean, I can take the thing and expand it, or I can zoom in. Oh wait, what are these control? Oh, I was about to flip my wig, really. But yeah, I mean, look at all these elements on the screen, which in this case, it's not. This one isn't adjusting. It's just giving me free form access. I don't have to fit everything. But I guess it's saying if that was not the case and you just wanted the layout to change based on how many of these, like, let's just say little blocks. Like if I pulled in a block and this one runs off screen down at the bottom and you wanted it to automatically expand to fit everything, then you would use a Z-stack. Okay. I mean, for my app, this is going to be dealing with, like, I'm going to have just two different builds for iOS and the iPad, one for portrait, one for landscape. So likely I'm not going to use a Z stack. I wouldn't need to, because I have a specific design in mind. So I guess I'll use overlay and background alignment. All right, for example, this code overlays a profile detail view on top of the image view. It overlays a profile detail view on top of the image view. So struct profile view with overlay, conforms to view, var body, opaque type, view. And then the VStack wraps this image. And then here's the overlay. So we want to resize it, maintain aspect ratio, and then overlay profile detail. Wait, overlay that over the image, which is in the VStack. Okay, no, that makes sense. And then the profile detail view itself that we pulled in here, or an instance of it, is an H stack wrapping a V stack, wrapping two view stacks. Oh, okay, that's the one from earlier. Yeah. Okay. And that's the in there. All right. So what is next? You can also find the documentation pages for HStack and VStack types in that section. You'll notice that stacks are also generic types, a common feature among most SwiftUI types. In our previous discussions, we've explored how to navigate this type of documentation. The content generic is constrained to the view protocol, indicating that stacks can contain any view. Declaring the content of container views inside view builders. Stacks introduce another facet of SwiftUI. Consider the initializer of the HStack type. Okay. Which is, initializer with 3 parameters: alignment, spacing, and content that we can pass to it. Why am I zoomed into it? Let me out of it. Cool. Escape is not working. Okay. I guess I just have to go back. Weird to consider that a link. All right, the content parameter. Let me punch back in here. Okay. Spacing and content. Horizontal stack, vertical alignment. So initializer, alignment, vertical alignment equals center. God damn it, I did it again. Equals center. Spacing is an optional CG float that defaults to nil. And then we have the property wrapper view builder for content. Empty tuple returns the content type. Okay. The content parameter adds 2 elements that might be confusing if encountered for the first time. Firstly, the empty tuple and the return type of content denotes a function type, suggesting that this initializer accepts a function as a parameter rather than a simple value. So a closure. Such parameters are typically supplied in the form of trailing closures. That is what allows you to specify the content of a stack inside curly braces. This won't be bad to review. These are... It's one of those things where it's like, it's simple and it's not. You just kind of gotta keep refreshing yourself on what the hell it means, and then it eventually will, find a resting place on your smooth brain. All right, so where's the... I saw that on a YouTube comment. I said it was some video explaining how memory models work. And that was the top comment. People really that really resonated with people apparently. It had like 800 likes. And it said, "Finally, an explanation that my smooth brain can understand." What a, you know, the self-loathing and self-deprecation is now like turned itself on its head. Now it's like people are accepting an award and praising their ineptitude, and people rally around that. We are dumb. We are less than. Like, I understand the. Never mind. I'm not gonna even try to understand it because I really don't. I really don't understand that kind of thinking. But yeah, it is what it is. Closures are self-contained blocks of functionality that can be passed around and used in your code. Closures in Swift are similar to closures, anonymous functions, lambdas, and blocks in other yeah, I mean, they are, that is what they are. They're just blocks. Closures can capture and store references to any constants and variables from the context in which they are defined. Oh wait, they're not, yeah, we did learn that. They actually do store things, which is something I still don't understand. Maybe we'll dig into that at some point. This is known as closing over those constants and variables. Okay, I interrupted too much. Let me interrupted myself. Let me reread that. Closures are self-contained blocks of functionality that can be passed around and used in your code. Yeah. And that was these things. So if we had like var, a thing is equal to bomb, and wait, where am I? Up, no, down. There we go. Up one more there. Okay. So the value bomb has this trailing closure, which is indicated by those squigglies, and then you would have the argument, whatever it is, the value. So argument value, and then the in is the keyword that separates the argument from the body of the function. So it's like writing a normal function, but it's a closure because it has no identity. You're just creating this function on the fly. But then you would have your logic. So you could do the argument value, +1 or whatever the logic is for your function. But that's what a closure would look like. So it just trails the actual variable, which in this case would be a thing. Oh wait, no, goddamn, I'm telling you wrong. Here I go. That is not what it would look like. That would be, or so a thing, and you could say, it's of type, int. Then you would just have your trailing closure. So it'd be like 1 + 5. But that's how you can populate a thing with some kind of logic using a trailing closure syntax. So that's what they're referring to. Whereas a normal function would have, a name, func, a thing, and then the arguments and some kind of, return type, and then the actual logic in the body. So they look similar, but you're not defining it. It doesn't have a function signature. You just are defining a function on the fly. All right, so where did anonymous functions? Yeah. Closures can capture and store references to any constants and variables from the context in which they're defined. Yeah, so if you have properties inside of a struct, your closure can access and use those properties. This is known as closing over those constants and variables. Swift handles all of the memory management of capturing for you. Don't worry if you aren't familiar with the concept of capturing. It is explained in detail below in capturing values. Okay. Global and nested functions, as introduced in functions, are actually special cases of closures. Yeah. Closures take one of 3 forms. Global functions that are closures that have a name and don't capture any values. Like a global function would be print. That's actually a global function. Nested functions are closures that have a name and can capture values from their enclosing function. So that would be one like, get the hell out of the way. Okay, so nested functions. So you could have enum, sticking with my, then you have trailing closure, or sorry, just the body of the enum, and then you can have var sum, and let's just say that's a type string, and then inside of it, nested functions would just be function one, and the arguments, oops, the return type, I guess it should be string too, string, and then its logical body, and then you can do something with, you could even do print sum, which is our variable from within the enum that we're in, or do whatever else to it. Doesn't really matter. But that would be a nested function, since the function itself is inside of the enum, a thing. So pretty literal in its description. Now the only thing that's a bit, I mean, we would also call those methods. Whenever you use that dot notation, that's how you access methods as well. Well, I guess that would be different because methods are only applicable to the type that owns them. Maybe they mean nested functions are just closures inside of a given type. Closure expressions are unnamed closures written in a lightweight syntax that can capture values from their surrounding text. Yeah. Swift's closure expressions have a clean, clear style with optimizations that encourage brief, clutter-free syntax in common scenarios. These optimizations include inferring parameter and return value types from context. Inferring parameter and return value types. Okay. Which through the inference, that just means that portion of the function signature where you, so if you have a function, let's do sigs, and then the arguments, the return type, that little arrow syntax, and then the type is optional. So based off the body of what's actually in the body of the function between the squigglies, whatever you do there, Swift can, oops, 2, 3, 4, 5, 6, 7. Swift can infer what the return type should be, so you don't have to explicitly call out the return type. But apparently, Swift's closure expression have a clean, clear style that encourage brief, clutter-free syntax. These optimizations include inferring parameter and return value type. So on the parameter type, well, I guess that makes sense because if you pass it a string, you're going to have to use, you're going to have to use double quotes. So it would be obvious that that's, string type, or if it's just a number, it would be an int, or if you did 8.0, then it would be a float or a double. So, okay, I guess that's not too outlandish. And then shorthand argument names, trailing closure syntax. Right, and that's what we were talking about. Okay, closure expressions. Matter of fact, I should probably just... I want to save this whole... This is a good page to save. Yeah, scrolling screenshot. Why not? And then we'll just come back up. Isn't that awesome, though? I mean, I'm telling you, just the best. It is the bar for web clippers. God damn, that is holy hell. Pretty wild. Add name. Yes, Swift. Closures. And Swift. Beautiful. Okay, so we were way the hell up here. Well, but then again, we did cover all this. I mean, this is Swift proper. I mean, this is not SwiftUI. The closures isn't Swift proper. So we did already cover it, but that's a good place to go back and reference just in general because we're not going to retain all of it, but I don't think we need to go back through it. So trailing closures. This is what allows you to specify the content of a stack inside curly braces. Yeah. Oh, I see. So those are, they themselves are closures in SwiftUI. Okay. The other crucial aspect is the @ViewBuilder attribute. Clicking on it directs you to the documentation page of the ViewBuilder structure. Okay, so which I thought we looked at this, but okay, so result builder attribute struct view builder. That's literally what it is. Overview. You typically use view builder as a parameter attribute for child view producing, as a parameter for child view producing closure parameters. Child view producing. Oh, okay. Yeah, okay. So meaning menu items being the parent view. Or sorry, context menu being the parent view, and then view builder for menu items. We would wrap menu items, which would be the child view. And this represents a closure here. So that just means it takes a function and returns menu items. Yeah. Clients of this function can use multiple statement closures to provide several child views, as shown in the following example. So in my view.context menu, and then the closure is everything between the first, well, sorry, everything between the squigs. This is just relative to the if block, but it can contain all of this. So 3 views, and then a conditional view. So 4 children. Okay. Topics, building content, static func build block, empty view, builds an empty view from a block containing no statements. Content. Wait, so this would be some type. The argument would be content. It returns a content type, and this passes a single view written as a child view through unmodified. Passes a single view written as a child view. Unmodified. Okay. Static func build block each content. Repeat each content. That seems cool, but I don't know that we saw what repeat and each. I feel cheated now. That seems useful. Actually, maybe we saw repeat once or twice. I don't know though. We'll come back to it. All right, so the crucial aspect, clicking on it directs you to the documentation view builder. Here you'll find that this structure is a result builder. Yeah, so view builder has yet another attribute over it, which is result builder. Result builders are advanced concepts only if you incorporate them to adapt. Result builders are advanced concepts only if you incorporate them to adapt Swift syntax to your domain. Mm. Okay. So if you wanted to have like an internal DSL, you could use that. Oh, that's pretty sick. Yeah. Yeah, we did that. We did kind of learn about in the Big Nerd Ranch guide. But yeah, that's pretty cool. Okay, but they're saying they're only advanced if you're trying to adapt them to some kind of rules or coding system you have, identification system you have internally uh, at your organization or relative to your product. All you need to know about view builders is that they allow you to list the content of any container view declaratively. Okay. All you need to know about the view builders that they allow you to list the content of any container view declaratively. Specify the context within its trailing closure without having to resort to intermediate constants and variables, which is impossible in standard Swift code. Oh. Okay. Returning to the view protocol documentation, you can see that its body property is also a view builder. Okay, so let's take a look at that. That is why you can also declare the content of a view even though this is a computed property and not a trailing closure. What? Returning to the view protocol documentation, you can see that its body property is also a view builder. Okay. So instance property, body, the content and behavior of the view. It's wrapped with a view builder. Main actor, still don't know what that is. Var body. Self.body, so the body of the type itself. And then we have a getter. When you implement a custom view, you must implement a computed body property to provide the content of your view. Return a view that is composed of built-in views that SwiftUI provides, plus other composite views that you've already defined. For more information about composing views. Okay, but this was earlier in the... What is never? Son of a gun. All right, so that is not really making sense to me. What? Okay, so first of all, what? How do I get a... Okay. What is the in Swiftline, what is the difference between a computed property and a trailing closure? How can I identify the difference when reading Swift code? Because I mean, they're both wrapped. I mean, they both follow the... Well, maybe that's not true, but whatever. Let's see what it says. Hey, babe. All right, let's break down the difference. Computed property. Computed properties, essence. A computed property doesn't store a value directly. Instead, it calculates or computes its value on the fly whenever you access it. Okay. Syntax, Swift, double. So this would be a computed property. So each time, oh, okay, that makes sense. Each time you access it, it's going to recompute width and height, even if it didn't change. So you would use this if you had a dynamic value that you would expect to change, and in real time you wanted to call it and refresh the value. Kind of like with the two-way binding. Get this block determines the value to return when you read the property. Oh yeah, we don't need to. Trailing closures, okay. A trailing closure is a syntactic convenience for functions that take a closure as their last argument. For functions that take a closure as their last argument, it allows you to write the closure after the function calls parentheses, making the code more readable, especially for long closures. Syntax. So SumArray.sort. Guess that'd be the method call. Then here's the function's body opening. And then we give it the tuple AB, so we're passing it 2 arguments, and it will return true, false. And then the logic return A is less than B, and it would be true or false. Okay. I didn't realize you could have the return type too in the closure. I thought it had to be inferred. That's cool, but still it follows what we saw earlier. The in keyword is separating arguments on the left and then the actual body. But so is sort also a function itself? Is that what it's saying? It must be. Trailing closure is for functions that take a closure as their last argument. Oh, so SumArray would be like whatever is here. Maybe, I don't know, we're out to ask. This is the same as SumArray.sort by, so that would be the parameter. SumArray.sort by, and then we start the function body, AB, still return bool, and okay, so that's the same. Okay, I mean, okay. Look for a function call where the last argument is a closure. The closure can appear inside the parentheses or as a separate block after the parentheses. If there's only one argument and it is a closure, you can even omit the parentheses altogether. SumArray.map. Okay, that's what maybe that's why, that's what I'm used to seeing. That's how we kept seeing it. That would be a key differences. Computed property calculates a property's value on demand, pass a block of code to a function. Does not store a value directly. Not related to storage. Syntax, curly braces with get set blocks. After function call with or without the surrounding parentheses. Area, full name, trailing closures, sort, map, filter. Export to sheets. Wow, that's cool. Example, putting it together. Swift, struct rectangle. Okay, so 2 properties, width and height, both of type double. Then another computed property called area. And then inside we have a getter. So whenever we were to print or use this area value, each time it's going to return back width times height. So if those change, then we'll get the new value. Okay, that makes sense. Yeah. I recall, and then let rectangles equal. So this is a constant now. Constant variable, and it's equal to, is that an array? What is this? Equal to rectangle. Oh, so okay, it's equal to this array of rectangles. So then we make instances of the rectangle, and we pass in width 3 and 4. So area would be 12 for the first one, and then 10 for the second, inside of our bucket here. Let sorted rectangles equal rectangles dot sorted. So sorted is a method, but then this closure would be the argument for the method. Okay. So okay. So if we went and looked at sorted, rectangles dot sorted, we would see in the implementation that it can take a closure as a as its argument, as opposed to a hard value. Okay, yeah, that makes sense. So let's go back and reread this now that kind of makes better sense. Returning the view protocol documentation, you can see that its body property is also a view builder. That is why you can also declare the content of a view, even though it is, even though this is a computer property and not a trailing closure. Returning the view protocol, you can see its body is also a view builder. I really just need to, we need to get into the example project, so I'm going to push past that, even though it's not, I was at like 40%, now I'm at 67, but it's still not really hitting yet. You can safely ignore the main actor attribute. Okay, we've seen this a few times. There you also find the main actor attribute we have not seen yet. This attribute is related to Swift concurrency. Oh, and is only useful when writing asynchronous code, such as when making network requests. In general, this is an attribute you can safely ignore. Okay. Well, for now at least. We won't be able to, because I mean, my app is going to go, it's all going to be async effectively, at least on initial load. Most devs ignore the wealth of functionality provided by SwiftUI. In our introduction to SwiftUI, we explored the basic building blocks of SwiftUI interfaces. However, we haven't seen any practical application besides what the code samples offer in Apple's docs. This intro should equip you to explore Apple's articles and the documentation of several types you can readily use inside your apps. Unfortunately, most developers miss the richness of the framework and try to reinvent the wheel when building standard interfaces. SwiftUI provides a wealth of functionality out of the box, which keeps increasing at every release. That will be the focus of the following modules. Okay, great. So that was just an intro, which is good to hear because, yeah, it's just good to know. We need to get way more nitty gritty. But yeah, I think we will call it quits for today, folks. To thank you for coming out. Per usual, please do drop a follow on every single social media platform you see on screen. Every single one. No, not really. But just to the one that you're watching on would be cool. So please do come back. We'll be on tomorrow. I'm tempted to push it to 12 p.m. Central Standard Time in terms of my start time, but I'm going to call it 11 again. And if not, I'll adjust the schedule. But yeah, we'll be back tomorrow for this Learn Along for episode 48. Otherwise, also check out my 9 p.m. Central Standard Time on this very same account. If you're watching on X or Twitch or wherever, where I'm playing Halo Ranked every single night for 100 days. We are on day 76, something like that, tonight. My road to Onyx, currently at Diamond 2 in my highest playlist. But yeah, check that out. Otherwise, see you guys tomorrow. Appreciate it. Go eat some lunch.